For the next few minutes, I just want to talk with you guys and show you, in case you ever want to study, about writing and naming ionic formulas. And ionic formulas are going to be, you'll recognize those by finding a metal. That's typically how we can do this. Now, there is one exception to that, but you want to look for the metal. Now, I have given you guys ion sheets, which gives you the answers. So if you want to have those out while you're going through this, that's probably a good idea. Now, just to go over this slide right here real quick, just so we're all on the same page. Again, an ionic formula will contain a cation and an anion, as it says right here. You'll have one cation and one anion. And this sets up a ratio between these two elements, okay? It's going to be a whole number ratio, a very simple one. 1 to 1, 1 to 2, 1 to 3, 2 to 3, 3 to 1, whatever. Okay, some rules that you should follow is the cations, or the metal, typically, the metal, or the exception is ammonia, is going to be written first. The anions are written second. Anions could be nonmetals, but the vast majority of them are something called polyatomic ions. And you just have to look those up. All right, the sum of the charges have to equal 0. I think you guys got that good. All the pluses have to equal the minuses. Now, they don't cancel each other out. It's just the sum of those charges will equal 0. You're going to use subscripts, which are little numbers. Parentheses will be used when I have to have more than one polyatomic ion. And since it's a ratio, we don't use charges in the final formula. We understand those charges are there. We're just trying to represent a ratio. Okay, doing a couple of these, we're going to write formulas. So when you look up your ion sheet, and by the way, if you ever need to pause to do these things, go ahead and do that. I'm just going to work, and you pause as you need. Potassium has a charge of +1. Fluoride has a charge of -1. I notice that the two charges, the sum is already 0. +1 minus 1 yields 0. The formula is simply Kf. With calcium bromide, I look up calcium, the charge is 2 plus, and the charge on bromide is -1. Well, it looks like I have to double up on the bromides in order to get this to cancel out. So +2 will equal out these two negative charges. That'll equal 0. The formula, CaBr2. Okay? The last one down here, strontium is +2, oxide is -2. They're already, now it's not a 1 to 1, it's not a 1 plus and 1 minus, but it is a 1 to 1 ratio, so therefore I can simply write just SRO. Okay, now you notice how I've been making sure those things balance out. Now there is another method which works the same way as what I've been doing, and that is the cross down method. With that, I'm going to find the charge on aluminum, the charge on nitride, and what I'm going to do is cross these things down. So I have Al3, N3. Notice I took that 3, wrote it down here, took this 3 and wrote it down here. Now, I'm not moving the charge. I'm just simply using those charges as a basis for the ratios. But since it's Al3, N3, I'll cross them out so I can get a nice, neat 1-to-1 ratio, and there's my answer. Aluminum oxide. There's aluminum again. Oxide is 2 minus. Now, I notice that 2 and 3 won't reduce to anything nice and neat, whole numbers. So what I'll do is cross down immediately. I'll put the 2 here. I'll put the 3 here. Al2O3. And there's my final answer. Now, the other way works too. I have to double up on my aluminums to get a +6 charge. And I have to triple up on my oxides to get a -6 charge. It still works out the same. I have 2 Als here, like right there. And I have 3 oxides here, like I do there. So either way works. Whatever way is more comfortable for you, make sure you use. Lithium's +1. Phosphate is -3. And so it looks like I have to use triple the amount of lithiums or cross the 3 down. It doesn't matter which you use. Either way, I'll have Li3PO4. Next, be careful with Roman numerals. Some Roman numerals you want to make sure that you keep in mind. Iron, lead, chromium, tin, what's another one? Copper. Our chromium's already there. Vanadium. There's a couple other ones, but these things that I have listed here are all elements that have multiple charges, and so we have to indicate the different types of these leads and irons and chromiums with Roman numerals. So you have to pay attention to that. Now, let's try a couple of those. So, iron 2 chloride. The charge on iron 2 is 2 plus. Fe2 plus. That's what the 2 stands for. Chloride is -1. All right, no big deal. So I put the 2 here. I put this 1 down here, FeCl2. Lead-4. The charge on lead-4 is 4 plus 4. Nitride is -3. Put the 3 here, put the 4 here. Pb3N4. Done. Chromium 3 sulfide, the charge on chromium 3 is 3 plus. Notice it always matches. Sulfide, 2 minus. Put the 2 here, put the 3 down here. You end up with Cr2s3. Done. Next, using polyatomic ions. Now, whenever you have polyatomic ions and you have more than one, you have to use parentheses. Got to use parentheses. If you only have one, don't bother with it. So here, I have lithium, which is +1. Nitrate, when you look it up, is -1. It's a 1-to-1 charge. So it's just LiNO3. I only needed one nitrate, so I do not use parentheses. This is a good final answer. With magnesium nitrite, magnesium is 2 plus. Nitrite is 1 minus. So it looks like I need to double up on my nitrites. That means I have magnesium, only one of them, but I need 2 nitrites. So I'm going to package it in parentheses and write a 2 outside. That's the only acceptable answer there. Iron 3 sulfate, Fe, 3 plus, sulfate, it's 2 minus. Looks like I got to put the 2 here and the 3 outside here. So it's Fe2, SO4, but I need 3 of them. So I'll put it in parentheses and put the 3 outside. And I know it's kind of sloppy here, but you can read it right there. Lead-4 hydroxide. Lead-4 is 4 plus. Hydroxide has a negative charge. So I have to use 4 hydroxides. The 4 goes down here. This 1 goes here. Pb, hydroxide is polyatomic, 4. Okay, moving on. A couple of these other ones right here. Ammonium oxalate. Ammonium is NH4 with a +1 charge. Oxalate is C2O4 with a 2 minus charge. It's really weird to see this, but it only happens on ammonia. The answer is NH4, but I need 2 of them, and I only need 1 oxalate. That's all he got. Okay? Okay, let's see what else we got here. Now, naming ionic formulas are real simple. You're basically going to read them right off your sheets. And you're going to pay attention to the whether the Roman numerals are there or not. For example, when I look this up, it's just barium chloride. Now, I gave you guys a tip in class, and that tip is you're going to look for a metal. Look for the metal. Metallic, 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 metal, 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 metal. Here's the only exception. If you see a metal, you use your ion sheets. If you don't see a metal, then you don't name it with your ion sheets. You put those away. Since this ammonia right here is the exception, you look. Let me add to that. It's ammonia and metals. You see metals and ammonia, you use your ion sheets. If you don't see that, then you don't name it this way. All right, so I look up on my ion sheet. Strontium is a metal. Strontium nitride. Okay, naming number 3. I find sodium sulfate. Okay, number 4. Magnesium. Flip the page over on your ion side, find the NO3 combination, nitrate. Okay, number 5. Cations are listed first, so I'm going to look for the NH4 combination on the cation side. I see it is ammonium. Flip the sheet over, look for the PO4 combination. That's phosphate, and that's its name, and so on. Number 6, 7, and 8 get a little tricky because chromium is going to have multiple charges. Chromium actually comes in a +2 or +3 charge. But if you remember, when I did this, I made a point to say that we crossed these charges down. So that means the charge on chromium is right here, and the charge on oxygen is right here, because you cross it down. So therefore, this has to be chromium 3 oxide, because the charge on this chromium is sitting right here. Same thing. Again, I cross the charges down. So therefore, what's the charge on copper? It's got to be plus 2. And the charge on hydroxide has to be minus 1. So therefore, this is copper, and you name the charge, 2 hydroxide. Okay? Vanadium can come in plus 2, or it can come in plus 4. Chloride only comes in minus 1. So I have to have a 1 to 4 ratio. Well, the only thing that gives me a 1 to 4 ratio is this plus 4, so it must be vanadium 4 chloride. Now, I've given you guys a bunch of ways to solve this. Okay, use your heads, look up the answers, cross down method, cross them back. Okay, just keep things straight. You should be okay. This sheet contains some of the harder ones. So when I look at this, again, all you're going to do is look up zinc on the cation side. HSO4 is a little bit more of an exotic one. Once you look it up, you'll realize it is called zinc hydrogen sulfate. Okay, number 10. Okay, once I look up lead, I realize that I have more than one lead that I need to deal with, and I could use lead 2 or I could use lead 4. When I look up perchlorate, I notice it only can be a negative 1. So what's going to give me a 1 to 4 ratio? Not the plus 2. So this has to be lead 4 perchlorate. All right, number 11 can be tricky because you'll notice that when you look up oxide, there is only one form of it. And so therefore, that is negative 2. Well, lead can be plus 2 or it can be plus 4. What is going to give me a 1 to 2 ratio? Well, if I pick this, plus 2 and minus 2 is a 1 to 1 ratio. That doesn't fit a 1 to 2 ratio. So it can't be this. It's got to be this. This will cross down. This will cross down. Essentially, I have Pb2O4. That will reduce to give me PbO2, which is what I have here. So what did I use? I must have used 4. The answer is lead 4 oxide. Same thing goes down here. Different argument. I can have copper 1. I can have copper 2. But I can only have sulfide, which is negative 2. This will give me a 1 to 2 ratio. That can't be that because it's a 1 to 1 ratio. So plus 2 minus 2, this has to be copper 2 sulfide. Okay? Hopefully that helps. Again, at the end of all these, I always say any questions, make sure you ask me, email me, st_kinkoff@smfcsd.org. And I'll see you the next day.